Hello Geometry. Today we are continuing Unit 13. We are doing the Day 2 notes in the, well, I want to say packet, but you don't have the packets. The Unit 13 Day 2 notes, the note sheets can be found on Canvas, or you can just do this on your own paper. We're continuing talking about area. One of the shapes we didn't cover yesterday was circles. So the area of a circle is going to be radius squared times pi. All right, and the circumference of a circle is going to be diameter times pi. The other option is 2 times radius times pi. So, for example, for these problems, what you're going to do is the area will be radius squared, so 7 squared times pi. This equal sign, where it's nice and straight, means exact, meaning no decimals. So you're not going to multiply the pi on your calculator, just do 7 squared on your calculator. You get 49 pi square centimeters. This one you'll notice is kind of squiggly. That means you're going to type it on your calculator with the pi symbol. Not 3.14, but pi. So you'll do 49 second and then this little caret key. After that you hit enter and you round it to I think it's usually going to be the nearest hundredth, so 153.94 would be your answer. 153.94 square centimeters. So this one is approximate, while the one above it is exact. Circumference is going to be diameter times pi, 2 times radius. This is a radius, so 2 times 7 times pi, which would be 14 pi. And circumference is not squared, it's like perimeter. And then for the approximate, you just do 14 second pi, hit enter, round to the nearest hundredth, you get 43.98 centimeters. So that's area and circumference. Polygons, okay? A regular polygon is going to be a polygon that is equilateral and equiangular. So all the sides are congruent and all the angles are congruent. All right. A central angle is going to be an angle, we learned about this already in our last unit, whose vertex is at the center of the circle, or in this case, a polygon. All right, so what's going to happen is, here's the center of our pentagon. If you were to make a bunch of radii, all right, this is an example of a central angle. Okay, central angle. Now, if we make a bunch of these, so we draw a radius to every single corner, you'll notice we have 1, 2, 3, 4, 5 triangles. And notice we started with 5 sides. The number of triangles will be equal to the number of sides. If you look at this angle here in the middle, if you go all the way around, that's a circle. That's 360 degrees. To figure out what each of these angles are here, what each of the central angles are going to be, you're going to take 360 and divide it by 1, 2, 3, 4, 5. All right, the measure of the central angle will be 360 divided by n, where n is the number of sides. All right, and that'll give us what each of the central angles are, and that'll come in handy when we do area in a moment. A radius is a segment drawn from the center to the vertex or corner of the polygon. Okay, so each of these green lines that I drew here, those are radii. An apothem is a little different. Apothem is going to be a segment drawn from the center and is the perpendicular bisector of the side of the polygon. So an apothem is going to go from the center straight down to the middle of the opposite side. All right, that's an apothem. A for apothem. All right, and then the formula is going to be area, capital A, not little a, area equals 1/2 times the apothem times P. P is going to stand for the perimeter. So to find the area of a polygon, you need to do 1/2 times whatever the apothem is times whatever the perimeter is. Okay, and we'll do that down below. So we've got a hexagon. Hexagon has 6 sides. All right, and the perimeter is 60. We know it's regular, so each of the sides are equal. So 60, you'll take 60, divide by 6 sides. Each of these sides is going to be 10. Okay, so each side is 10. We need to figure out what our central angle is. All right, if we were to draw a bunch of radii, we'd end up making 6 triangles. So we're going to do this, the measurement of the central angle is going to be 360 divided by n. So if we do that, we're going to do 360 divided by the number of sides, 360 divided by 6. Each of these angles is going to be 60 degrees. Okay, so you can draw all of them if you want, or just one of them. All right, so down here, if I drew another central angle, this angle would be 60. However, we need to find the area 1/2 times the apothem, which we don't have, times the perimeter, which we do have. The apothem is what we need to find. So I'm going to draw an apothem down here. The apothem is going to go straight down here. It's going to be the perpendicular bisector. So this piece 10 is going to be cut into 2 equal pieces, 5 and 5. This is our apothem here. And then what was a 60-degree angle is being cut in half by this apothem. So we're going to have 30 degrees each. What I'm going to do is I'm going to take this section here and kind of draw it off to the side. I'm going to take this triangle here and just kind of draw it over here so it's not so squished. So if we do that, we've got this triangle here. This is a 30-degree angle, this is our apothem, and this piece is 5. You're going to need to remember your 30, 60, 90s, which we did a while ago. Across from the 30s A, across from the 60s A root 3, and across from the 90 is 2A. So across from the 30s A, so we know what A is. All right, not to be confused with A for apothem. The cross from the 60 is going to be A root 3, and then across from the 90 doesn't matter. We don't even need that piece. We just need this piece, the apothem. If A is 5, this piece is A root 3, so this piece has to be 5 root 3. Just plug the 5 in for A. So we've got that. So we know what our apothem is. We know what our perimeter is, and now we can plug it in. Area is 1/2 times the apothem, 5 root 3, times the perimeter, 60. And you'll notice the directions say give an exact answer when possible. So we're not going to multiply the root 3 on our calculator. Just multiply 1/2 times 5 times 60. 1/2 times 5 times 60 is 150, root 3. And then the units will be square centimeters. All right. All right, let's do some different shapes. The next one is an octagon. All right, 8 sides. This time we don't know the perimeter, we know the apothem. Okay, what we're going to do is we're going to find out what our central angle is. All right, to find our central angle, you do 360 divided by the number of sides. Since there's 8 sides, it's going to be 45 degrees. Okay, so what was a 45-degree angle will now be cut into 2 equal pieces with this apothem here. So this angle here will be 22.5 degrees, as will this one over here. What we need to figure out is the perimeter. So what I'm going to do is I'm going to draw just this section kind of over here. So let me draw this over here so it's a little bit bigger. All right, so what we have is we have our radii drawn here. All right, and then we have our apothem here, which is 12, and this is 22.5 degrees. And what we're going to do is we're going to find out what this piece is here. I'm calling it x. Once I know what x is, I know that this piece will be the same, and then we can find the perimeter. This one's not a 30, 60, 90 triangle. Instead, it's a 22.5-degree angle. We don't have like a quick way to do that. So we're going to have to go back to some other old stuff. We're going to be using sine, cosine, and tangent. So remember SOHCAHTOA. All right. So I'm writing them all down here. You got sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent's opposite over adjacent. So old stuff coming back at you. Here's our angle. This side here is the opposite side because it's across from it, doesn't touch it. And this side here is the adjacent. Remember the hypotenuse is always across from the right angle. So this piece here, even though we're not using it, but that's the hypotenuse. So we've got opposite and adjacent, which means we're going to use tangent. So we're going to do the tangent of the angle, 22.5, equals opposite x over adjacent, 12. And then you cross multiply. You're going to do 12 times the tangent of 22.5. When you do this, make sure your calculator's in degree mode. So on your calculator, you'll go to mode and make sure it's in degree mode. All right. All right. Then what you'll do is you'll do 12 times the tangent of 22.5. We're going to get decimals. We round to the nearest hundredth. It's 4.97. So x equals 4.97. So if this piece is 4.97, this piece here is 4.97, which means that the entire side is going to be 4.97 times 2, you get 9.94. So each side is 9.94. To find the perimeter, you're going to do 9.94 times 8. So multiply that guy by 8, you're going to get 79.52 as your perimeter. Meters. So now we can find the area. It's 1/2 times the apothem, 12, times the perimeter, 79.52. And when you multiply that all out, you get 477.12 square meters. Okay. Number 3, same idea. We have this time a pentagon that we're given the radius. Let's find the central angles. So we're going to do 360 divided by 5. If you do 360 divided by 5, you're going to get 72. All right. Which means that once we cut that 72 in half with the apothem, we're going to get 36 degrees each. Sorry, that should be a 36. So 36 degree angle here, 36 degree angle here. All right, we need to find the apothem and we need to find the perimeter. So we've got a lot to find. Let me draw this section over here. All right, so you've got this and we've got 36 degrees here, X and 9 and A. So it's up to you which piece you want to find first. Again, we don't have like a 30-60 or 45-45, so we're going to use SOHCAHTOA. I'm going to find, let's find, I don't know, we'll find X first. So we're going to use 36, X and 9. This is the opposite side. This is the hypotenuse. Opposite and hypotenuse would be sine. So we're going to do the sine of 36 equals opposite over hypotenuse. Cross multiply, I'll do 9 times the sine of 36. So you can do that on your calculator. 9 times the sine of 36. You're going to get 5.29. So X is 5.29. Let's do the apothem. So we'll use 36, A, and 9. I would not use 5.29 since that was rounded. We want to have exact answers or as close as possible. A is the adjacent, 9 is the hypotenuse, so we're going to use cosine. Cosine is adjacent over hypotenuse. Cosine of 36 equals A over 9. Cross multiply, so you're going to do 9 times the cosine of 36. You can do that on your calculator like so. You're going to get 7.28. A is 7.28. All right, so we've got our apothem. We've got to find our perimeter. If this is 5.29, this is 5.29. Double that. Let's see, 5.29 times 2, you're going to get 10.58. So each side of our pentagon is 10.58. Since there's 5 sides, we're going to multiply that by 5 to get our perimeter. Perimeter is 52.9. Okay, so we've got our perimeter, we've got our apothem, now we can find our area. Area is 1/2 times the apothem, 7.28, times the perimeter, 52.9. And you multiply that out, you're going to get 192.56 square millimeters. Okay, what I'd like you to do is I'd like you to try number 4 and number 5. Keep in mind special rights for some and trig for others. Go ahead. So let's see how you did. For the pentagon, you're going to take 360 divided by 5 like we did in number 3. Each of the angles, central angles, is going to be 72. The apothem cuts that in half, creating a 36 degree angle. The perimeter is 80, so you're going to do 80 divided by 5 equal sides. Each side is 16. So notice this whole thing is 16, and then it gets cut in half to 8 and 8 each. So we're going to do trig. We've got the opposite and the adjacent and the 36. We're going to do tan 36 equals 8 over A. You're going to cross multiply. This time you have to divide by tan of 36. You're going to get 11.01 for the apothem. Once you have the apothem, you have the perimeter. Plug it in. 1/2 times apothem times perimeter. You get 440.4 square centimeters. For number 5, what you're going to do is take the 360 divided by 6. Each angle is going to be 60, but then the apothem cuts that in half, creating two 30-degree angles. The apothem here is 12. This side we don't know. Because it's a 30, 60, 90, this side's A, this side's A root 3. So we know that A root 3 is equal to 12. So that's what I did here. I set A root 3 equal to 12. To get rid of the root 3, I divided by root 3, and then I have to rationalize. Multiply the top and bottom by root 3. Reduce, I get 4 root 3. Perimeter then is going to be 4 root 3 plus 4 root 3, that's 8 root 3, times 6 sides, you get 48 root 3. 1/2 times apothem times perimeter, you get 288 root 3.